Stupid as it sounds, we actually weigh ships all the time, and there are a number of reasons why we do it. Imagine you want to move a lot of cargo. Maybe you've got a huge amount of coal that you want to sell. You know roughly how much you have, because you kind of measure your pile. But when someone's going to be buying 20,000 tonnes at $100 per tonne, they want better than a rough estimate. They want to know exactly how much they're paying for. Now you could weigh the whole pile of coal, but that's not really practical. You could weigh it as you lift it onto the ship, but again, that would take ages. The simplest solution is actually to just weigh the ship. You can weigh it once before loading, and then again immediately afterwards, the difference giving you the amount of cargo that you've loaded. And what about a passenger ship? Do you weigh every passenger and bag as they board? Actually no, we make a rough estimate, and then we weigh the ship to check the numbers. Remember back to the video on cruise ship stability, the calculations that we used there all relied upon the weight of the ship to keep it stable. So back to the main question, how do you weigh a ship? Well, not actually using a set of scales. I doubt there's a set anywhere in the world capable of weighing 500,000 tonnes. Instead, we turn to our friend Archimedes. Effectively, a ship will displace its own weight in water if it's going to remain afloat. To weigh the ship, we just need to know how much water it displaces. Ships and boats are designed by naval architects who model the exact shape of the hull. They give us a set of tables that we use to work out how much cargo a ship can safely carry. For different weights, these tables tell us how low she will sit in the water. Now the beauty of maths is that it works both ways. Instead of working out how low she will sit for a given weight of cargo, we can work out the weight from how low she is sitting. So how do you know how low a ship is sitting in the water? If you've been up close with any ship, you probably noticed the numbers written on the side. These are the draft marks, and they measure how low the ship is sitting. The numbers count up from the bottom of the ship, starting at 0 at the keel and continuing up to the deepest draft she could sit at. Most will give metric readings, effectively giving you the draft in meters, though there are countries that do give the draft in feet. I believe the USA is the biggest one that's still doing that. For metric draft marks, you'll notice they sometimes give whole meters, and then they seem to count up in 20 centimetre increments. Others give decimeters instead. Of course, 20 decimeters is 2 meters, 30 decimeters is 3 meters, and so on. Again, these go up in 2 decimeter increments, effectively measuring every 20 centimeters. But if you look a little deeper, they're actually counting in 10 centimetre increments, and that's due to the height of the digits. When the water is at the bottom of the number itself gives the draft. When it reaches the top of the number, it's halfway up to the next digit. In this case, the bottom of the number measured 2 metres 20 centimetres. The top of the number is 2 metres 30 centimetres. It all seems very simple, and it is when the ship is sitting perfectly upright and perfectly trimmed. Unfortunately, this is virtually never the case. So, to help us, draft marks are located at 6 points around the ship. You've got the forward port and starboard, midships port and starboard, and the aft port and starboard. Reading all 6 of them will give you a much better idea of how a ship is sitting in the water. It will tell you about any bending in the hull, and that's actually normal, and it's so normal it's named hogging and sagging. If you do read all 6 drafts, you can actually then calculate an average, which you can work with. That average draft then allows you to work out the volume of water that's been displaced by the shape of the hull, using those loading tables that we talked about earlier. Finally, to convert that volume into a weight, you just need to multiply it by the density of the water. Now we typically work with 2 different densities. Seawater has a density of 1,025 kilos per cubic metre, and freshwater's got a density of 1,000 kilos per cubic metre. Due to the variations, we actually measure the density of water that the ship is currently sitting in. Finally, to work out the overall weight of the ship, you just take that volume of water that you've calculated your ship has displaced, and you multiply it by the density of the water that you've just measured. It might not be as simple as just putting the ship on a set of scales, but scientifically, it's the simplest way for us to weigh a ship. Hopefully you've enjoyed today's video. Until next time, thank you for watching, and goodbye.